is we're going to start here is we're going to look at graphing a rational function manually. So I want to be able to do it manually as well. The first thing we need to do is determine any vertical and horizontal asymptotes. So you determine the vertical and then determine the horizontal. And we're going to make a table of values that determines the y-intercept, find the values close to the vertical asymptote, find large values and small values of x, and then draw a smooth curve through the points. Now these are 4 steps with an additional 3 in part 3. Let's look at an example. We'll come back to this. Now, here we have graph this function. This is a fairly straightforward function. If we look back, the first thing we need to do is find any vertical asymptotes. And remember, the vertical asymptotes are where the denominator is equal to 0. Now in this case, we can probably just look at this one because it's already factored. So we know we have a vertical asymptote at x equals 2. That's where our vertical asymptote is. Okay, what about a horizontal asymptote? Well, the degree of the numerator is, well, there's no degree, there's no variable, so it's 0. The degree of the denominator is 1. If the degree in the numerator is less than the degree in the denominator, there is a horizontal asymptote at y equals 0. So we have both vertical and the horizontal asymptotes. So let's sketch those in. Let's draw those in. Now with an asymptote, what we do is we do a dotted line. So we go to the line, x equals 2, and we draw ourselves in a dotted line. Now, let's draw in our dotted line here, just like so. And we have a vertical asymptote right there. Now we have a horizontal asymptote at y equals 0, which is right here. Just like so. So all we've done so far is determine the vertical and the horizontal asymptotes. And remember, the asymptotes are values that the graph will never cross. So that's where we have the values that the graph will never cross. So now let's look back here, because we've done 1 and 2. Let's look at 3. We're going to make a table of values that determines the y-intercept, and we're going to find values close to the vertical asymptotes. Because what we want to do is we want to determine the behavior of this graph close to those asymptotes. So let's go back and make ourselves a table of values. So table of values. We're going to have, again, we're just going to pick values that make sense here. So let's pick x values and f of x. And it can be red. Let's change it back here. So let's determine the y-intercept. That's where x is going to equal 0. So when x equals 0, and we're going to do this all with mental math here. If we put 0 in for x, we're going to have 1 over negative 2, which is the same as negative 1/2. So I have 1 point already on my graph, and I can just put it right on my graph. I'm at 0 and negative 1/2. Now I'm going to pick points close to my vertical asymptotes. And in this case, it's just a single asymptote. So I'm going to pick x equals 1. I'm going to pick x equals 1.5, or 1.5. I know I can't pick 2, because 2 is not allowed. I'm going to pick 2.5, and I'm going to pick 3. Just values close to that asymptote. So when I put x equals 1 into here, I'm going to get 1 over 1 minus 2, so that's going to be 1 over negative 1, which is just going to be negative 1. Now for 1/2, 1.5, I'm going to show you a little bit here. This one might not be quite so easy to do in your head. So we're going to have 1 over 1.5 minus 2. That's the same as 1 over negative 0.5, which is the same as 1 over negative 1/2. And remember, if we're dividing by a negative, or dividing by a fraction, it's the same as multiplying by the reciprocal. So we actually get negative 2. So at 1.5, we're at negative 2. Now if we've done 1.5, 2.5 is easy, same mental math. All it is makes it positive a half in the denominator, which makes it 2. And if we put 3 in there, 1 divided by 3 minus 2 is just equal to 1, so we have 3 and 1. Now, I went through those quickly, but if you need to, you can go through and figure out each of those individually and find those points. And all we've done is we've determined points on our graph. So 1, negative 1, we're right here. 1.5 and negative 2, we are right here. 2.5 and 2, we are up here. 3 and 1, we're right here. And I could pick more points if I wanted to, but now what I do is I just draw a smooth curve. And what we're going to have here is a sketch of what it looks like. It's going to get closer and closer to those asymptotes, but never touch. Same thing over here. Closer and closer to these asymptotes, but never touch. Just like so. And there's the graph of our function.